Starting chapter 4, 4.1. This is a little more about fundamental data types. This is number types. Again, there's only two we're really going to deal with, ints and doubles, but there are a few more types, and just to show you how they work and what they do. So in Java, every value is either a reference to an object or belongs to one of your 8 primitive types. That would be table 1 on page 135, shows you all the primitive types. 6 of the primitive types are numbers. We're going to use ints for integer quantities. However, you have to be careful that there is, since an integer has a range of about 2 billion, it only has 4 bytes. Okay, so that's the size that it can hold as far as representing in binary, turning either a signal on or off. And if you go more than that, you're going to have a problem. You can get what's called an overflow. So if you look on page 134, for instance, if we say something like int n, integer n equals 1 million, and then I want to print n squared, so system out print ln n times n, I'm going to get an error. It's actually going to print negative 727379968, which is absolutely not what we wanted. The reason being is that it's too big to fit. It's about 10 to the 12th, and I can only fit 2 times 10 to the 9th. Okay, so that would be an overflow. I physically can't fit as many digits as I need in the size of an integer. So that's one potential problem. It's not usually a problem if we're going to use a double. Double range is about plus or minus 10 to the 308th power with 15 significant digits. You do notice you have things like longs and shorts, floats, and things like that. Those are just different types. If you're really concerned about your efficiency and how much memory space your program's taking up, you can start chopping up the memory space. But we're not going to really worry about that. One thing you do need to be worried about is this concept of a rounding error, okay, when you're using doubles. And that's because of how a computer is going to store the value. Rounding errors will occur when exact conversion between numbers is not possible. So for instance, if I went double f equals 4.35, and I said system out print ln 100 times f, we would expect it to print 435, but it actually ends up printing it's way off. 434.999 da da da, and it ends up like a 4. Okay, that's because of how computers represent your binary numbers. There's no exact representation of the fraction 1/10, so it sort of fudges a little bit. So a double obviously would not be useful for an actual bank, and we're going to keep but since we're using small sort of simple programs, it'll be okay. And on the AP test, that'll be okay, although you do need to keep in the back of your head, rounding error could occur. Okay, in Java, a few things to remember. I can assign an integer into a double. So int dollars equals 100, double balance equals dollars. That is okay. The compiler is going to pitch a fit on the other way, okay? We can't go backwards because it just doesn't fit because of how much memory space is allocated for a double. So you couldn't say something like double balance equals 13.7 or 13.5. Put a decimal point in there somewhere. And then say something like int dollars equals balance. That's an error. Okay? What you could do is you have to do what's called a cast, okay, which is to sort of force the compiler to be okay with it. I could do something like int dollars equals int balance. So a cast is anytime. So remember how we converted graphics G to graphics 2D by a cast? It means I'm going to force the computer to allow me to change what I'm using. Now, BlueJ will sometimes still pitch a fit for loss of precision, but that's all right. The problem with a cast, if I'm going from an int to something like, so like say I had 13, so dollars is 13.5, and I cast it, it doesn't round, it just chops it off. So dollars at this point now just equals 13, which is a bit of a problem. Okay, so you would need to round if you wanted to round. Okay, the casting tells the compiler that you agree to information loss. In this case, the loss of the fractional part. You can also cast other types, like float or byte. If I wanted to round a floating point number to the nearest whole number, use math.round. This method returns a long integer because large floating point numbers cannot be stored into an int. So, page 136, you would do something like long rounded equals, now it's a static class that you don't have to import it. It's available. So math.round, it's the round command of the math class that doesn't have objects, okay? So it's because it's static, you could do this and that would then round it up to the nearest integer value. All right, get a few more of these. 4.2, concept of constants. Okay. In many programs, you need to use what's called numerical constants, values that do not change and that have special significance. Or if they change, the user's never going to change them. If you wanted to change them, that way you only have to keep rewriting it. You only have to change it once. Okay. So if you look at the example on page 140 where it's like payment equals dollars plus quarters times 0.25 plus dimes by 0.1, nickels by 0.05, etc. So if I had, for instance, pennies times 0.01, well, if you grew up in the U.S. with our monetary system, you would know that each penny has a value 1/100th of a dollar or 1 cent, and so I could take the number of pennies I had and multiply it by 0.01 and get the dollar value, essentially. However, that wouldn't necessarily work for everybody. So you'd want to use symbolic names, things that make sense, and set them up beforehand. So, and traditionally it's going to be all capitals to denote and easily make it easier to read what a constant would be. So I could say something like double quarter value equals 0.25. But that still lets me change it. So if I want to tell the computer that this cannot be changed and not to allow anything to change it, I'm going to make it a constant and use the final variables. I'm going to make them final variables, use the keyword final, and write it as all uppercase. All right. Oops, let me give myself some room here. So you put final in front of double. Okay, that tells the computer this, don't let anybody change this. And then again, traditionally, all capital. Okay. If they're going to be used in several methods, then I should make them what's called static, so that I could use them and make them a variable of my class, or a constant, of my class. So any method in my class could use it. And then you're going to tag it with the keyword static. So it would be something like public static. Remember, static just means, we'll get into it more later, but static means it doesn't operate on any sort of an object. This is for the class only. So public static final double quarter value equals 0.25. And then any method could use quarter value, and you just have to call for it. And there are a few the math class has, such as e and pi, which are already set for you. And so you could just use them. For instance, you could write something like math.pi. Whoops, that's spelling pi the wrong way. Pi. Math.pi, and it would automatically give you the whole number. So if you look at the cash register class on page 143, and then the cash register tester, it's got a few constants in it. So we'll go ahead and open that up real quick. So in my cash register class, You can see I've got public static final double quarter value. So these aren't instance fields, these are class constants. I make them final so they cannot be changed, and I make them static so that they are the class. Anything in the class can use quarter value. I want to redefine it. Then I have my two instance fields. All right, then my constructor. All right, I just make a cash register, no payment, no purchase is done. Record a purchase with an amount. I save that. And then enters the payment received from the customer at param dollars, the number of dollars, etc., etc. Public void entered payment, int dollars, int quarters, int dimes, int nickels. And then so here all I'm doing is saying however many dollars you got times, well, no times because that's their own value, time plus the quarters times the quarter value constant all the way up here at the top. And then add them all up, and then give change. I take my payment, I subtract the purchase cost. That's the difference in my change. I do then reset my whole thing to 0 and return my change double to the user. Okay, so the nice thing is if I say I were to use up here, I used to use quarter value many times, but then it wouldn't be quarter value, but it's something else of some other constant, and I wanted to change it later on. If I wrote it like this, I'd only have to come up here and change this one time, and it would propagate through my entire program because I was using this constant instead of having to actually type it in. All right, so let's look at the tester real quick. So create a new cash register using the keyword to invoke the constructor. Record a purchase 75 cents, record a purchase of $1.50, enter payment $2, no quarters, and 5 dimes. Print out change, call my give change should be 25 cents, reset, and do it again. All right, one thing you do want to be careful of is if you look at page 145, you don't want to use magic numbers, okay? So for instance, something like h times, what does it have, h times 31, something like what in the world is 31 for? It can represent a lot of different things, the number of days in a month, one less than the number of bits in an integer. This is actually your code, part of your code for a hash code computation, but you wouldn't want to use that. So you want to use a named constant to make it very obvious. For instance, 3.14159. Okay, if you're thinking geometry, you're thinking that's pi. Otherwise, it could be any sort of number. So that's what's called a magic number. You don't want to use anything that shows up with no explanation. So a comment, but even better than a comment would be something like final int hash multiplier equals 31. That way I can just call hash multiplier, and anytime I use it, it's very obvious what I'm using. Another thing you don't want to do, okay, to make something like this kind of redundant, would be like final int, instead of like days per year, to call it like 365. So you wouldn't have, like 365 equals, 365. That would be kind of dumb, right? It needs to have a useful and obvious name, hash multiplier, pi. Something that as soon as I go to use it, I know exactly what it is, and there won't be any confusion. Also, the other thing is you don't have to worry about mistyping it. If you spell hash multiply wrong, it's going to tell you it has a uninitialized variable, and you don't have to worry about putting, because if you put in 31 every time, except for one time you put in 30, the computer will happily set 30 in there because it doesn't know what you actually wanted it to do.